Welcome to the DIY Honda Garage channel. DTC P0113 indicates an issue with the intake air temperature, IAT sensor circuit, specifically a high voltage reading. This diagnostic trouble code, DTC, is part of the Powertrain Control Modules, PCM, program for monitoring the engine's performance. The IAT sensor plays a crucial role in measuring the temperature of the intake air, which is essential for the engine management system to adjust fuel injection and ignition timing effectively. Located near the mass airflow MAF sensor, it uses a voltage signal to report air temperature back to the PCM. A high voltage reading signifies that the circuit may be shorted to voltage, damaged, or that the sensor itself may be malfunctioning. This guide will help you systematically troubleshoot the P0113 code to identify and rectify the issue. The IAT sensor is critical for ensuring optimal engine performance by providing the PCM with accurate air temperature readings. This sensor is located in conjunction with the MAF sensor, typically found within the air intake system of the Honda CRV. The sensor operates based on changes in the air's resistivity, converting temperature readings into voltage signals sent to the PCM. A high voltage condition, as indicated by the P0113 code, implies a malfunction may exist in the sensor or the wiring that connects it to the PCM. Typically, a properly functioning IAT sensor should produce voltage readings below 4.92 volts. Understanding the IAT sensor's role and location allows for focused diagnostics to resolve the circuit high voltage issue effectively. Multiple factors can lead to the P0113 DTC being triggered. A faulty IAT sensor itself is one probable cause, which might not accurately reflect the temperature readings due to internal failure. Additionally, loose connections at either the MAF sensor, IAT sensor terminals, or at the PCM can create inconsistent electrical signals, leading to high voltage readings. Voltage issues can also stem from damaged wiring in the circuit paths, particularly the TA and SG2 lines, which could interrupt the proper communication between the sensors and the PCM. It's vital to explore each of these areas during the diagnostic process in order to identify the source of the high voltage reading conclusively. The presence of DTC P0113 can manifest in several noticeable symptoms impacting the vehicle's performance. Drivers may experience poor engine performance, characterized by hesitations, stalls, or rough idling. Typically, this is due to the PCM being unable to adjust fuel and air mixtures appropriately because of the incorrect readings from the IAT sensor. Additionally, the vehicle's check engine light, CEL, will be illuminated, alerting the driver to a fault within the engine management system. Inconsistent fuel efficiency may also arise as the vehicle struggles to maintain optimal operational parameters due to the erroneous signals from the IAT sensor. Recognizing these symptoms enables timely diagnosis and repair of the underlying issues associated with DTC P0113. The first step in troubleshooting DTC P0113 involves verifying the problem through a simple electrical check. Begin by turning the vehicle to the on mode, which powers the vehicle's electrical systems without starting the engine. Next, using a Honda Diagnostic System HDS tool, check the voltage reading of the IAT sensor. The expected threshold for this reading should be less than 4.92 volts. If the current conditions indeed exceed this threshold, you have duplicated the failure condition, verifying that the fault is present. However, if the voltage is within the acceptable range, this indicates an intermittent fault. At this point, you should check for poor connections or loose terminals at both the MAF and IAT sensors, as well as the PCM. Capturing an onboard snapshot of the DTC may assist in replicating the failure under the same conditions later. In this second troubleshooting step, focus shifts towards isolating the exact component causing the issue. Start by turning the vehicle to the off lock position, ensuring all electronic systems are powered down. Disconnect the 5P connector for the IAT and MAF sensor. Using a jumper wire, connect terminals A and B of this connector. Return to the on mode to allow electrical signals to flow through the jumper. With the HDS tool, again, check to see if the IAT voltage reading exceeds 4.92 volts. If it does, this indicates that the MAF sensor IAT sensor has likely failed and should be replaced. Proper isolation of the sensor through disconnection verifies if the issue resides within the sensor itself or if it is somewhere else in the circuit. For this step, you will identify potential failure areas within the wiring related to the IAT sensor circuit. Begin by turning the vehicle to the off lock mode to safeguard the vehicle's electrical and electronic systems. After ensuring the vehicle is powered down, remove any jumper wires previously connected to the IAT and MAF connector. With the vehicle still in the off mode, turn it back to on, making sure the MAF sensor IAT sensor connector remains detached. Measure the voltage between the specified test points to check the integrity of the circuit. The expected reading should be around 5.0 volts. If this reading is confirmed, proceed to the next step. However, if the voltage differs significantly, additional wiring inspections will become necessary to locate the fault. Now, dive deeper into troubleshooting the SG2 wire, which may be contributing to the high voltage issue indicated by DTC P0113. Begin by turning your vehicle to the off lock mode to ensure all electrical systems are offline. Use the Honda Diagnostics system to jump the SCS line to prepare for testing, and wait for at least 1 minute to allow the system to adjust. Afterward, disconnect the PCM connector C51P to isolate it from the diagnostic process. Check for continuity between the identified test points. You should check the connection between the MAF sensor/IAT sensor connectors terminal 2 and the respective terminal number 31 at the PCM connector C51P. If continuity exists, you can confirm the SG2 wire is functional. If not, you will need to repair an open circuit in the SG2 wire between the PCM and the MAF sensor/IAT sensor. In the final troubleshooting step, you will perform a continuity check on the TA wire, which is essential for proper circuit functioning. First, switch the vehicle to the off lock position to ensure no electrical interference. As before, utilize the Honda Diagnostics system to jump the SCS line and wait for more than a minute. Once done, disconnect the PCM connector B51P to isolate it from the circuit. Similar to previous steps, measure the continuity between specified test points, this time between terminal 1 of the MAF sensor IAT sensor connector and terminal number 51 at the PCM connector B51P. If continuity exists, the TA wire is working correctly. If you do not find continuity, you'll need to address the open circuit in the TA wire connecting the PCM to the IAT sensor, restoring the functionality of the circuit. Once repairs have been conducted following the previous troubleshooting steps, a thorough verification process is crucial. Start by performing a system reset using the HDS, clearing any existing fault codes from the PCM. Following this, conduct a road test of the vehicle under various driving conditions to ensure all systems are functioning optimally. Observe whether the check engine light remains off and confirm that no new diagnostic trouble codes, DTC, have appeared during or after the test drive. If all signs indicate the system operates normally, The repair process for DTC P0113 will be considered complete. This validation step ensures that not only the symptoms have been addressed, but also confirms long-term repair success and vehicle reliability. Preventive maintenance is an essential aspect of avoiding DTC P0113 and ensuring the longevity of your vehicle's engine management system. Conduct regular checks on the IAT and MAF sensors to ensure they are clean and functioning correctly, as dirt and grime can lead to inaccurate readings. Inspect all electrical connections periodically, looking for signs of wear or corrosion that may affect sensor performance. It is crucial to replace any faulty or outdated sensors promptly to maintain accurate air measurement, improving engine efficiency and performance. Additionally, keeping up with scheduled maintenance practices can assist in ensuring that your Honda CRV operates smoothly and without interruptions, reducing the chances of setting DTCs in the future. In conclusion, diagnosing and repairing DTC P0113 involves a systematic approach that traces back from the IAT sensor to the PCM. We reviewed how the sensor functions, its critical role in the engine management system, and the various possible causes for the high voltage condition. Monitoring for symptoms, like poor performance and check engine light activation, helps signal any issues early on. Employing the structured troubleshooting steps ensures that faulty components are identified and rectified promptly, thereby restoring functionality. By embracing a regimen of preventative maintenance and timely repairs, owners can sustain the health of their Honda CRV, promoting reliable operation while minimizing the risk of future DTC occurrences. Please like and subscribe to the channel. See you next time.